Hi everybody, this is Dino Chris from Prehistoric Facts, and today we'll be doing an extra episode, and somebody suggested to me that we should do one of my favorite topics to talk about is Tyrannosaur Evolution. And of course, many of you know Tyrannosaurs and basically Tyrannosaurus Rex is my favorite dinosaur. And so I have done this topic before for a paleontology class one time, and so I'll give the lowdown of what I did in that. I'll give you the information that I did for that presentation, but also add a little more information about this as well. All right, first off, let's actually start off where Tyrannosaurs kind of came from. If you look at the dinosaur family tree, basically the theropod family tree, you actually see it begins all the way into the Triassic, basically, with Eoraptor or Herrerasaurus. And those two dinosaurs pretty much set the motion into basically what theropods would look like. But I'd say Herrerasaurus is probably more into the herbivorous dinosaur kind of path, but even though we'll see how what more information is needed for that. And basically the group of dinosaurs that Tyrannosaurs belong to is actually the Coelurosaurids, or the Coelurosauria family, and pretty much they're different from the Allosaurs, the Carcharodontosaurs, and the Spinosaurs, which kind of actually belong in the Carnosaur, or otherwise not-existent Carnosaur family, basically. These kinds of and there's a lot of differences between the Coelurosaurs from the Allosaurs, Carcharodontosaurids, Spinosaurids, all those kinds of carnivorous dinosaurs that you would think that they're probably closely related. Well, first off is that Coelurosaurs have longer, slender legs than the Carcharodontosaurids, Allosaurids, and the Spinosaurids. So basically, they were faster runners. And also, the Coelurosaurs kind of actually almost the Coelurosaurs were very more closely related to birds than the Allosaurids, the Spinosaurids, and the Carcharodontosaurids. So the Coelurosaurs would actually start to become birds. So pretty much that actually kind of sets the motion for where Tyrannosaurs kind of belong. Now, where Tyrannosaurs belong, they're kind of actually the basal Coelurosaurs. Basically, they're near the bottom of the Coelurosaur family tree, and so they're not as advanced as, like, say, the Dromaeosaurs or the Troodontids. So pretty much those dinosaurs would actually see Tyrannosaurs would actually be considered kind of almost like the basal Coelurosaurs, but even though they probably did have feathers, so pretty much like that. And where Tyrannosaurs actually began, they began in the mid-Jurassic, and so that actually starts off with the Proceratosaurids. And now these dinosaurs are more closely related to Tyrannosaurs than to Ceratosaurus itself. Now these dinosaurs would actually have crests or nasal horns, basically nose horns, and pretty much they were used for display, basically. And then basically you move on to that category of the early Tyrannosaurs, and then pretty much you actually go down to some more still small, but even though starting to almost look like Tyrannosaurs. And that's where you get animals like these two, basically, because you got Guanlong and Dilong. Now, Guanlong could almost be considered a Proceratosauride, but even though, I still need more evidence to support that. And both of these dinosaurs are found in China, so you could actually almost consider that Tyrannosaurs kind of started out in Asia, but even though there's some that actually have been found in Europe. And so Guanlong is pretty much a very primitive Tyrannosaur, along with Proceratosaurus, and also Dilong. Now, Dilong or Dilong, is either way you want to call it, are both primitive tyrannosaurs. Now, Dilong or Dilong is actually a little bit more advanced than Guanlong, and basically it's because Guanlong has the ancestral look of a crest on top of its head for display, whereas Dilong or Dilong doesn't have that. They don't have a crest on their head, so pretty much they're a bit more advanced. So they would have probably been a lot faster than Guanlong and probably a bit smarter than Guanlong. And they were pretty much capturing smaller prey like amphibians and reptiles and even smaller types of dinosaurs like the early Psittacosaurids and all those kinds of dinosaurs. But then after that, you actually kind of move into when Tyrannosaurs were starting to become a little bit bigger and also show the actual traits of Tyrannosaurs, like Raptor Rex. Raptor Rex is starting to show the features of what would become Tyrannosaurs. Basically, large head, small arms, and pretty much long, slender legs, and kind of showing the basic traits of Tyrannosaurs. And that's kind of an interesting thing, and when you actually look at that, because you see, if you actually look at that kind of transition, you actually kind of see that, like, hey, it's got some of the similar features like some of the bigger Tyrannosaurs have. But also in that mix, we're still with the primitive Tyrannosaurs, Tyrannus, one of the more recent discovered Tyrannosaurs. Tyrannus is actually the Tyrannosaur that has actually been found with complete feathers covering its body. Now, these wouldn't actually be like the feathers that you would actually see in modern, like in flight birds, or otherwise like the dromaeosaurs probably had. They were probably more, kind of like a downy type of feathers, basically, kind of almost like say what a primitive chicken would actually kind of be, you know. And then when you actually go down that tree, you actually go into dinosaurs like Appalachiosaurus. Now, Appalachiosaurus is the only Tyrannosaur that's been found in the eastern part of the United States, found in Alabama. But even though we still need to find out if it does show that dinosaurs were living in the east coast of the United States during the Cretaceous, and those formations have been ignored a lot for many years, just because they thought that dinosaurs would never actually have existed in this type of area. But I'd say that there are dinosaurs that have lived in the eastern part of the United States in the Cretaceous, during when the Western Interior Seaway was starting to being developed, and also kind of actually go along that way. But I'm pretty sure that there were Tyrannosaurs that were living in the eastern part of the United States, and I think that's going to be a really good point of basically where we still need to look at those formations a little bit better, so that way we can actually get a better understanding of what the ecosystem was in that particular time. But after that, when you actually get to after Appalachiosaurus, you actually start to see some of the bigger Tyrannosaurs, the more common Tyrannosaurs that we actually kind of recognize as Tyrannosaurs, like Electrosaurus, and Daspletosaurus, Gorgosaurus, Albertosaurus, and basically with kind of like with Albertosaurus and Gorgosaurus, here's the maxilla of Albertosaurus, and pretty much this is when Tyrannosaurs were starting to get bigger in the late Cretaceous, and you see in the late Cretaceous, Tyrannosaurs kept evolving, and that's basically it's because the climate's changing rapidly, and so that actually supports the idea that Tyrannosaurs were quick to evolve, and also they had the brain power to actually do it, and so and of course with Albertosaurs, you actually see that they're they're still large, but even though they're not the largest of the Tyrannosaurs, of course, they're actually very speedy type of Tyrannosaurs. They actually use speed to actually capture their prey. But they would actually also do ambush as well. Adults would have done a little bit more ambush than actually than chasing their prey, but even though they can still do it. And of course, like with the Gorgosaurus and Albertosaurus, you actually have teeth that are not really designed for crushing bones that much, but even though they can still crush bones. But they're more designed to actually to cut through flesh, basically. They will penetrate bone on occasion, but even though they probably didn't have the jaw power like some of the later Tyrannosaurs. And of course, with Albertosaurs, here's a hand of an Albertosaurus. And you see, because with Eutyrannus, Guanlong, and Delong, you actually have 3 fingers on their hands. But when the bigger Tyrannosaurs start to come about, you see they're starting to lose this 3rd digit in their hands. This is a vestigial finger. Basically, vestigial means that it's starting to go away, basically. And that's how that's kind of happening here, is that their arms are getting smaller while their body size is getting bigger. That's why you have the bigger skulls, bigger bodies, bigger, stronger legs, and muscular tails. But the arms are starting to become much, much smaller. And when you actually look at these arms of Tyrannosaurs, you actually see that their forearms, these 2 bones, the radius and the ulna, are actually starting to get really, really reduced. In Albertosaurus, it's really distinct, and also in Tarbosaurus, it's very distinct. Tyrannosaurus rex, nearly distinct. And this is what the body plan of Albertosaurus would have actually looked like. Kind of a very streamlined head, still have forward-facing vision, good binocular vision. So the smaller arms, had the strong, long legs, and a muscular tail, and very powerful jaws as well. And with the Spletosaurus, it's kind of becoming more robust type of Tyrannosaur, and that's where you actually start to see those kinds of Tyrannosaurs starting to take off later on. And there's one Tyrannosaur I kind of forgot to mention, is Chianzosaurus. And it's basically that newly discovered Tyrannosaur that has this really long snout. So those long snout Tyrannosaurs were not really good bone crushers. They were basically to grab and hang on and also strip flesh, basically. They were not really well designed for crushing bones. So they would have been really fast, but not really good power type of Tyrannosaurs. And then when you get down to the later Cretaceous, basically, the very end of dinosaurs, you actually get like Zooxantheranus, Tarbosaurus, and Tyrannosaurus rex. And those are the dinosaurs that would be the more powerful of the Tyrannosaurs, basically. Now, when you think of Zooxantheranus, and also Tarbosaurus, because they would have been around nearly the same time. Zooxantheranus is more like the power Tyrannosaur. Basically, uses muscle a little bit more than speed, whereas Tarbosaurus would have been using speed a little bit more, not enough power. But even though Tarbosaurus would have still been a pretty powerful Tyrannosaur, and of course you get Tyrannosaurus rex, and that is the biggest of the Tyrannosaurs, and pretty much the most powerful of all the Tyrannosaurs. Could there be a Tyrannosaur bigger than T-Rex to be found? Maybe, but we still don't know. We still don't know if there were any bigger Tyrannosaurs. And other small Tyrannosaurs, like Eotyrannus, I forgot to mention, those were very rare Tyrannosaurs, but even though their fossils have been found in Britain, but even though they're very rare. But let's actually get down to the the classic features of Tyrannosaurs. First off is the skull, and this is the replica model of Stan, one of the most complete Tyrannosaurus Rexes ever found, and Stan actually has one of the most complete skulls of any Tyrannosaurus Rex that has been found. And this is the best skull to actually look at, and to actually look at all the features of Tyrannosaurs from the skull. And basically, let's actually start with the snout. The snout is actually very round up front. It's round up front. So kind of when you actually put your hands right over here, is like I'm doing right over here, you can see how it's kind of sliding around. That's a good indication that Tyrannosaurs had a kind of like a U-shaped snout. So pretty much they were using their skulls very differently than what other carnivorous dinosaurs did. Because other carnivorous dinosaurs, they actually kind of have this V-shape type of skull, basically, where they have very little teeth in front of the snout, and then pretty much they just use their teeth in the maxilla and also in the mandible to actually strip flesh, basically. A little bit easier than what a little bit kind of meat slicers, basically. Tyrannosaurs are actually doing something very, very different. And of course, when you actually get down to right here, let's actually talk about some of the places where the senses would have actually have really good indication of what their senses would have been. Let's actually start with the nostrils. The nostrils are actually kind of large, and also they're a little nearly spaced apart. But even though that shows a good indication, that's a really good indication of a good sense of smell. And Tyrannosaurs have a very good sense of smell. And let's actually talk about the eye sockets. The eye socket would have actually been right here. Now, a lot of people would actually, and to a lot of the public eye would actually think like this is the area where the eye is. It's not. Right over here is where the eye is. This is called the antorbital fenestra. Here's the orbital where the eyes would have actually been placed. And the interesting thing about where the eye sockets are actually placed is you can see the eye sockets are actually facing forward. And so this is a adaptation for a predatory behavior, basically. Much better predatory behavior, and this shows good binocular vision, and that's what Tyrannosaurs were actually doing, much more different than what other dinosaurs were doing, other carnivorous dinosaurs were doing. It's because having forward-facing vision, you can actually judge distance a lot better, you have better depth perception, and also you're actually be able to see better. You're actually going to see better a lot more than what the other carnivorous dinosaurs would have done. Other carnivorous dinosaurs, they had their eyes placed towards the sides, so basically they were going to look one direction over the other. And that's kind of also to keep an eye out for other predators that are going to be coming in. Tyrannosaurs, they still have this adaptation, but even though it's much more different. You see, they're going to judge distance, but even though their eyesight is going to be much more widely ranged, and also their heads would have turned much more quickly than what other carnivorous dinosaurs did. That's why Tyrannosaurs have very large neck muscles. And right over here, where the hearing would have actually have been, even though you can't see it very well, but the hearing of Tyrannosaurs is very, very good. They can actually hear low-frequency sounds. And with Dr. Larry Whitmer's work with scanning brain cases of dinosaurs, he's actually shown his evidence has actually shown that Tyrannosaurs had very large brains for giant carnivorous dinosaurs, and also they have very much well-adapted senses. So basically, they're able to see, smell, and hear a lot better than what other carnivorous dinosaurs would have actually done. And also, they would have actually able to actually use that information from their senses a lot easier than what other carnivorous dinosaurs did. Dromaeosaurs would have actually done the same thing, but a lot better. And of course, the teeth. The teeth of Tyrannosaurs kept evolving over over millions of years. I'm actually going to try to get this done quickly here. So, the teeth of Tyrannosaurs are actually starting to get thicker and thicker, and that shows of bone-crushing abilities. And this is the tooth of a Tyrannosaurus Rex. This is one from Stan, and see, they're still very serrated teeth, but also very thick. So that shows they're able to crush bones much better than what other carnivorous dinosaurs did. And a good evidence of why Tyrannosaurs are kind of closely related to birds is the wishbone. This is the wishbone of a Tyrannosaurus Rex. It would have been placed right here, and pretty much wishbone is a really good indication of close resemblance to birds. And of course, like with all Tyrannosaurs, long, slender legs for good speed and power, and also their tails are very long and muscular and able to help them for balance. So pretty much able to actually do this a lot easier than what other carnivorous dinosaurs did. Now, I'm going to get into behavioral aspects, maybe for a part 2 segment. So I'm probably going to tape a part 2 segment later on, so you guys can actually get the part 2 of Tyrannosaur Evolution within a couple hours. So hopefully it'll actually work out pretty well. All right, and I'll do part 2 pretty soon, and I'll see you guys a little bit later.